Okay, we are starting module 2 of API 570 Piping Inspector. This module we are talking about body of knowledge, and you shall learn about reference documents, general tips on document navigation, important terms and definitions. API Authorized Piping Inspector certification exam is designed to determine if applicants have knowledge of maintenance, inspection, alteration, and repair of in-service metallic piping system. You should know about Piping Inspection Code 510, Piping Inspection Practices 574, Positive Material Identification 578. You should also know about process piping, ASME B31.3, pipe flanges and fittings B16.5, welding inspection and WPS, ASME section 9 and API 577, NDT, ASME section 5, damage mechanism, API 571, and finally have sufficient general and safety knowledge. The API 570 Piping Inspector examination has two sets of reference and study materials. One set is ASME codes, section 9, B31.3, B16.5, and API inspection code. The other set are recommended practices 571, 574, 577, and 578. So if you want to differentiate it or categorize them based on codes and recommended practices. The open book part of exam are either calculation type of question using formulas or requires you to refer to the reference material. You need not memorize, but should know where to look for when solving the open book question. Therefore, you should have a fair idea how to navigate through reference codes and recommended practices during open book part of the exam. So when reading a code and a standard, don't immediately dive into the details, get the bigger picture. First, understand what the code covers by reviewing the opening paragraphs of each code. This is generally called a scope or introduction. Next, look at the table of contents to understand how the code is structured. It helps you to have a fair idea of where to look for. List of figures and list of tables can be used as plan B if you cannot find a particular piece of information from the content list. This step is often overlooked and the inspector fails to get the scenario, the purpose of the code, and how to locate the information. We have flagged important pages of codes within each module and also brought important information in the flashcards. These information are potential exam questions. Our mock exams, quizzes, and flashcards are designed to test your knowledge, help you understand how to interpret, and check if you missed something we explained before. The closed book questions are coming straight from API and ASME codes. These are the information and knowledge that an inspector will be using on daily basis, and therefore you need to memorize them. API calls them practical questions. But don't worry, we shall supply you with enough presentation, mock question, and flashcards to ensure that you would not forget them during the exam. The second set of reference documents contains the recommended practices 571, 74, 77, and 78. Again, we have summarized them, highlighted important information, and explained the underlying reason whenever necessary, so you can grasp the concepts. Most of the practical type of questions are based on experience and are common sense, really. Around 40 to 45% of exam questions come from API 570. Please note that only API 570 is a code, mandatory, while the rest of API documents are recommended practices, good engineering practice. In a nutshell, closed book questions mostly come from API 570 code and recommended practices because this type of information is supposed to be used by the inspectors on a daily basis. For open book questions that need referring to tables, graphs, and formula, you shall have access to both the recommended practices API 570 and ASME codes. Okay, let's have a look at the reference materials covered. First one is API standard code 570, inspection, repair, alteration, and re-rating of in-service piping. Then there is damage mechanism. You got around a dozen sections that we have brought in the module. Then you have 574 inspection practices for piping system components. Then there is welding inspection and metallurgy API 577. 578 material verification program for new and existing alloy piping system or positive material identification, which is actually we normally call PMI, but PMI is part of this API 578 because it's a material verification program. So it says, for example, if the material is non-compliant, how you quarantine it, or how you deal with it, etc. Then ASME code 31.3 process piping. Then you have ASME B16.5 pipe flanges and flange fittings, and then we'll cover ASME section 5 articles 1, 2, 6, 7 and 23, and then we would cover WPS, PQR and WPQ. That's welding procedure specification, procedure qualification record, and welder's procedure qualification from ASME section 9. Okay, before going to the relevant section, you need to know which document you need to look at in order to find a particular topic. Therefore, you need to know what is covered in each code and recommended practice. If you are in doubt during the exam, look at the table of contents. If it does not help, look at the list of figures or list of tables. It shall give you an idea where you can find the topic. For smaller documents, peruse through the table of contents or figures. Try reading the PDF format of documents on a desktop or laptop so your eyes and mindset gets used to them. Seems the brain works differently when you're looking at a hard copy of a document than when you peruse through soft copy of the same document. Reading soft copies of reference documents help acclimatize oneself while searching for a topic. A little practice is necessary to get it right. It's particularly useful for bigger codes such as ASME section 5 and 9, ASME B31.3, ASME 16.5 and API codes. This looks like huge documents, but don't worry, we will highlight and list all the pages and tables that you should frequent and know where it is. Also, try to memorize the topics of codes and recommended practices so you know where to look for. If you can't find the relevant section after a couple of minutes, flag off the question. Note the question number on a piece of paper, as there is a high chance that you shall find it when looking for answers for other questions during the open book exam. Once found, you can go back to the flagged off question and solve it within seconds. You are also advised to practice looking for topics in PDF format. API code 570 and API recommended practices 571, 74, 77, 78 should not be a problem navigating, as they are much smaller compared to ASME code. Obviously, you can quickly peruse through the table of contents for recommended practices, but still you should need to have a fair idea where you can find the topics, and this is not possible unless you start practicing going through them. We have highlighted the important topics between each code, standard and recommended practices. Please note that the reference codes and recommended practices provided during open book part of the exam are not word searchable, hence you should know where to find each topic. But don't worry, we have highlighted and listed important section of codes, so you should not find it difficult to find the right code and section during the exam for most of the exam questions at least. Okay, vocabulary. we're bringing a few important vocabulary here so you know the basics or refresh your mind. And these are the important vocabulary of API 570 course. And we have explained it in a simple language. Now, order of precedence. Normally in every project or there are several codes and standards, but in case of conflict, they always would sort of give you an order of precedence. For example, although API 570 is the governing document that overrides even ASME B31.3 for in-service piping, API code 570 cannot be in conflict with any regulatory requirement or jurisdictional regulation or government regulation unless it's more stringent than them. Obviously, if API code is more stringent or more onerous than a regulation, this means it's not in conflict, but it's over and above that regulation. Examination. By examination, it means QC activities of particular entity. It's not an inspection. The closest analogy could be the difference between a laboratory blood test examination and doctor diagnosis inspection, which includes evaluation and interpretation or acceptance rejection. Examination report shall be approved by the inspector. Entity technician examines the material by one of the entity methods and report the result. Entity examiner can also report the acceptance or rejection of a material or equipment against an approved acceptance criteria if authorized by the inspector. In any event, it is the inspector who shall approve the examination report. Please remember that the inspector is the final authority in accepting or rejecting the QC and entity examination report. Imperfection, discontinuity, defect. Discontinuity is a distortion in the material. If it is unacceptable, meaning the size of discontinuity is beyond the acceptance criteria, then it's called a defect and is therefore rejectable. Otherwise, the discontinuity is acceptable. Remember, a defect is also a discontinuity, but a discontinuity may not be a defect unless rejected. You have to compare the discontinuity against the acceptance criteria and decide whether it's acceptable, in this case termed discontinuity, or unacceptable, in this case known as a defect. Imperfection and discontinuity, there is a slight difference, but they are used interchangeably. Evaluation versus interpretation. So before you accept or reject a discontinuity or imperfection, you have to first know what it is. So evaluation is actually intended to find out the reason behind the formation of discontinuity and categorizing it and telling us whether it's a porosity, crack, lack of fusion, gas hole, stringer, and C. So once you know what is it and the size of it, then you interpret it, which means comparing the discontinuity against an approved acceptance criteria and determine whether is it below that acceptable limit or above it. So whether it's acceptable or should be rejected. Obviously, you first need to evaluate the discontinuity and then interpret it. Means know what it is and what is the size. So that's called evaluation, and then you interpret it, accept it or reject it. Accuracy versus precision. So precision and accuracy are often used interchangeably, but in science they have very different meanings. Measurements that are close to a known value are said to be accurate, whereas measurements that are close to each other are said to be precise. So accuracy is used for calibration purpose to determine how accurate the readings are with respect to a known value. Precision shows variations. So how close are a bunch of thickness measurement reading at a point on the vessel. The point of measurements normally means a circular area with a diameter of 3 inches. Owner user. API always uses the term owner in conjunction with user. So it's always owner/user because it does not differentiate between owner and user. It makes sense because if owner and user are differentiated as two separate legal entities, then none of them could be held accountable, because the owner would say that the user was supposed to comply with jurisdictional requirements, while the user would argue that the pressure, the piping belonged to the owner and they should be held accountable. So owner user is accountable for any shortcoming and non-compliance to code and specification or jurisdictional requirements. API 570 requires that an owner user shall employ or subcontract an inspection organization or an inspection program, an authorized inspector, a repair organization, an engineer, an inspector, and examiner. Please note that the ultimate responsibility lies with the owner user, while other individuals are accountable to the owner user. Inspector means API 570 piping inspector. So the inspector is responsible to the owner for inspection and approval of the vessel for continued safe operation. The inspector can be an individual working for the government, jurisdiction, and insurance company, for a third party under contract with the owner user, or directly for the owner user. NDT examiner is responsible to carry out NDT activities as per approved procedure, and if authorized by the inspector, can also prepare the acceptance and rejection part of the report. However, please note that the inspector is the final authority in accepting or rejecting the NDT reports, as well as all the inspection records. Certification of the NDT examiner shall be maintained by his/her employer and shall be available for inspector's review. This term is because the NDT examiner, normally the NDT activities are subcontracted. So the employer of the NDT examiner should make sure that this certificate is in date and provide it for inspector's review. Engineer is the one appointed by owner user and is an individual or a team with sufficient knowledge in design, review, analysis, and evaluation of piping. So both the engineer and the inspector shall approve any re-rating, derating, and alteration. However, the repairs does not normally need engineer's approval unless the inspector opts to consult or choose to consult with the engineer. Corrosion specialist, an individual knowledgeable in materials, metallurgy, damage mechanism, and corrosion monitoring techniques, and is approved by the owner again, like engineer. Integrity operating window means those parameters that is the piping or is supposed to operate, and the most prominent one would be the pressure range and temperature range, but the fluid and the velocity of the fluid and the type of the fluid might also be integrity operating window parameters. This range is determined by the design and depends on the type of material and thickness. Exceeding the IOW range may affect the integrity of the piping. Management of change. Any change in the process equipment or material or hardware shall be documented. It shall be determined whether such changes may affect piping, say by increasing corrosion rate, or change the damage mechanism. Relevant personnel such as the engineer, corrosion specialist, inspector, examiner, and maintenance personnel may be involved to cascade or inform such changes to inspection for inspection planning, repair, and maintenance purpose. Condition monitoring locations are points or areas on a piping that are identified that normally expect to have the highest corrosion rate or stress concentration. These areas are inspected and examined periodically to assess the piping. The locations are selected to be representative of corrosion behavior of the piping. It makes sense to select those points or areas where maximum corrosion or damage is expected. The inspector selects the monitoring location based on previous history of inspection, damages occurred on similar vessels under similar operating or environmental conditions, and may seek corrosion specialist opinion on expected damage mechanism for the particular vessel. QA and QC. QA, or quality assurance, means design and planning of quality control activities while quality control is the implementation of those control activities. Quality assurance manual is a system that includes organization, quality control and quality assurance procedures, reports, records, inspection plan, risk-based inspection assessment, determination of inspection interval, auditing, drawing, calculation, repair, re-rating, management of change, compliance with codes and spec, records of qualified welders, NDE technicians, and approved WPSs, training, material traceability, and material certificates. As you can see, this is more or less a list of ISO 9001 requirements. Remember that the owner user is ultimately responsible for preparing, documenting, executing, and assessing piping inspection and repair. Temporary embrittlement, reduction in toughness, means temporary embrittlement when 2.5 chrome 1 mole low alloy steel exposed to high temperature range of 650 to 1100 degree Fahrenheit. Remember that embrittlement is the reverse of ductility. Hardness is the resistance of material against penetration or indentation. Toughness is the resistance of material to deform under forces and or stress. Is quantitatively the area under the stress strain curve. Toughness depends both on amount of stress it can tolerate and its amount of elongation. Toughness of a material is determined by Sharpie impact test. Thank you for listening to our Module 2, and next we will start Module 3. Thank you guys.